Hi guys, Mrs. H here. So today we're going to be taking a look at acceleration. So in order to do this, let's go ahead and review what velocity is. So remember, velocity includes speed of an object and the direction. So when we're describing somebody's velocity, we're looking at how fast are they traveling, so how far are they going during a certain period of time, and what direction are they going in that period of time. So, what is the difference between speed and velocity? Well, velocity is a vector, so it also includes the direction, where speed is not a vector, it's scalar, and it just tells you how fast. And so, why is that important to understand that vocabulary word? Well, acceleration is the rate at which velocity changes. So, what are we really asking when we're talking, or what are we looking at when we're talking about accelerating? Well, we're looking at, is an object speeding up? Is an object slowing down? Or is an object changing its direction? Or is it both changing its speed and its direction? If any of those things are happening, then an object is said to be accelerating because the velocity is changing. So anytime you have a change in velocity, you have acceleration. So that's what it means to accelerate, is when you're speeding up, you are changing your speed. You are changing your velocity, so therefore you're accelerating. Same thing if you're slowing down. I'm changing how fast I'm traveling. So I'm changing my acceleration. So I'm changing my velocity. So I'm accelerating. And it can be just turning a corner. If you turn a corner, you're changing your direction. And so you are again accelerating. So when we say acceleration, we have to remember acceleration has direction because that's important. And we also have to look at acceleration being positive or negative and what those things mean. So if I am changing my direction, but I'm going away from the origin, that could be a negative acceleration. Or if I'm slowing down, I can have a negative direction. I could be slowing down in a negative direction, but then that would be a positive acceleration. So let's look at how we solve acceleration problems. So let's look here. A car travels 60 miles per hour around a curve. Is this car accelerating? Well, yes, because they're changing direction. Even though they're not changing their speed, because they're changing their direction, this car is accelerating. Now, same car, but now they're going in a straight line. No longer accelerating because their speed is the same and their direction is the same. So again, yes, because it changes direction, or no, because it's not changing speed or not changing direction. So changing direction is considered an acceleration because remember that definition of acceleration, it's a change in velocity. And if you remember, we just said that direction is included in velocity. And so just by changing your direction, you can change your acceleration. So centripetal force is a uniform change in direction. So centripetal force is really an acceleration. So when the earth is spinning or a dog chasing its tail, so this is a centripetal acceleration. So let's look at how we solve these problems, because that's what you're going to be looking at, is calculating acceleration. So we say acceleration equals the change in velocity over time. So we look at our final velocity minus our initial velocity, and we divide that by time. So here's an example. If you're traveling at 40 meters per second and slow down to 20 meters per second, and that takes you 20 seconds. So I need to first identify my numbers. So this one right here, this is my initial velocity. This is my final velocity, and this is my time. So I need to plug that into my equation. So 20 minus 40 over 20. So 20 minus 40 is a negative 20. So negative 20 over 20 seconds is 1 second. And now here's the thing. We need to keep our labels. So how do we label this? Meters per second, right? Because we didn't get rid of that. So a negative 1 meter per second over 1 second. And so what do we have? A negative 1 meter per second. Oh, and that's squared. Not up here because it's meters per second per second. That's the labeling on an acceleration. Meters per second per second. Okay, so don't forget that. That's a new label we're seeing here. Now, what does the negative tell us? It tells us it's a negative acceleration. Why is it negative? Well, because it's slowing down. So if you have any questions on how to solve these problems, please make sure you reach out to me. The biggest thing you want to make sure you're doing is identifying before you do anything, identify your values. What are your values? And then put those values into the equation. So look at your numbers in your problem, then put them into the problem and then solve. Bye, guys.